Hello everyone, next I will introduce ItsMiner. ItsMiner is a professional Bitcoin mining management and hash rate monitoring software. This is our website. You can view company and software information and register or log into our software here. Let's go to the login page. You usually need to register through your phone number. You can log in by phone number or username to log into the system. Okay, let's log into the system first. Usually, when you already have a mining farm in operation. Enter this interface, it will look like this. On the left is a summary of data across multiple farms, including total miners, total hash rate, and the status of all miners, such as their failure status, invalid miners, how many miners are offline, under repair, and the total revenue situation, and the number of customers. On the right side is the situation of each farm. There are also some summaries above. This section shows farm sub-accounts of the pool, overall earnings, and the number of clients across all farms. You can click Create to create a new farm. The most important thing in this is that you need to choose the correct time zone. In addition, you can also join another mining farm by using its farm ID. Now let's enter specific mining farm. After entering, there will usually be a start guide, which is a guide to using the user manual. Then you can follow the instructions to configure the system step by step, and then the system can be used gradually. For each step, there are detailed help instructions. You can check it out. These have detailed help instructions, and each step has it. Let's go back to the system itself. The system has two main parts: configuration and daily monitoring, operation and maintenance management. In terms of configuration, the first is the basic configuration of the farm, including name, location, and time zone. Time zone settings are critical. Selecting the correct time zone ensures more accurate data statistics throughout the system. Another basic configuration item is the monitoring server setup. When you receive our hardware monitoring server, you can take the send code on the monitoring server. Take it and then here to configure this hardware monitoring server into it. Then configure the IP network segment you need to scan, which is where your miner are located. All these network segments. Then we can add network segments in batches, like this. Once you add the network segment, the system will start in the background to continuously scans the state of the miner. You can already obtain the data of the miner. If some users have changed their password, you need to put in the new password here. Here are the monitoring rules, where you need to set parameter ranges for each type of miner. When the system detects values outside the configured range, it will be flagged as in fault. For example, you can say that a certain model normal high temperature is 90 Celsius. If it exceeds 90 Celsius, we will think it is a high temperature fault. These are the system default configurations. which you can adjust to suit your local environment and miner conditions. At this time, the entire miner can be fully maintained. There are also some automated operations. You can configure some items to run in the background automatically. For example, you can configure which miners trigger under specific conditions, such as certain faults or excessive temperature thresholds. Of course, there can be multiple conditions. In this case, then I will restart it, or switch to sleep mode, or add it to a temporary task list, and assign it to someone to do maintenance and so on. This is an automated task running continuously in the background. Let's take a look at user and permission management. You can create multiple users for different colleagues in the farm, or invite users who already have ItsMiner accounts. Both methods are acceptable. Then we can assign different modules. In addition, you can assign them miner operation permissions, such as restarting operations. We can specify that user demodmin may restart up to 60 miners in batches. However, users ItsMiner and Near can restart a maximum of 200 miners without any special configuration. All users in the mining farm default to a limit of 50 restarts. Our system also supports customers to authorize the hosted customers in the mining farm. Here, you can configure how many miners to restart in batches. If you don't want him to perform this operation, you can set it to 0. Then he cannot restart the miner. Okay, this is the user and permission module. This is the subscription module. Here you can view the number of miners you own, your miner quota, capacity calculated by load, and how much you have used. Here you can also view the billing date. You can set a specific time every month to complete a cycle summary. It includes items like income summary, periodic stage recap, power consumption data, and electricity bill computation. You can set different dates. Okay, this is our basic configuration function. Although there are many configuration options, you only need to set the time zone and IP network segment. Once done, you can perform regular miner operation and maintenance. You may add and modify configurations gradually. After configuring the IP network segment, when you go back to the daily operation and maintenance page, you will see a large amount of data displayed here, especially in the workers section. On the interface of the list of miners, you can directly see all the real-time data of all the miners. Let's first give an overview of the daily. The monitor module. It includes several parts. The first few are the dashboard, workers. Then, there's inspection, mining pool, and earning. These modules serve the operation and maintenance team. They are mainly applied for fault handling work. In the electricity asset team, client management is mainly used by the operators of the mining farm. There are some small functions here, which we will introduce gradually later. First, let's take a look at these two dashboards. This is the basic dashboard page. Mine operators mainly operate on this page because it includes the data of the miners. It includes both local data and mining pool data, situation of sub-accounts, earnings situation, electricity status, and the situation of client custody, and so on. It is a summary of the entire operation of the farm. The operation and maintenance dashboard is mainly for the daily work of the O&M team. It delivers more in-depth and detailed operational status data, such as the working mode, the running status of the miner, and also the most, where the most faults occur. We have a fault arranged by racks. That is to say, the most faults occur in the rack of room 1R5. When you prioritize faults on the rack, your hash rate can recover faster. This dashboard greatly improves fault handling efficiency for operators. It supports sorting out faults by priority in advance. The page of the miner list is a typical interface. The top of it shows the status of the miners, the total number of them, plus how many are running, how many are normal, faulty but still hashing, 0 hash rate, how many are in the off rack, and how many are in the repair stage. The right side is classified according to specific conduct miner statistics by fault classification. You can directly filter here. And there are more filtering conditions here, such as by the miner's IP segment, or the configured rack, by brand and model, working mode, firmware, IP type, status, what task it is currently performing, which client it belongs to, which sub-account of which pool it is configured. All of these can be filtered in this way. Then on the miner list interface, after filtering on the miner list page, we can open the miner to view its detailed information. For this miner, we can check some of its detailed information, its current various running state parameters, 24-hour hash rate curve, the temperature curve of the 24-hour hashboard, some IPs, mining pool, and some customer configuration information, and the status of each hashboard, including the status of the chips on each hashboard. Mining pool configuration. All the operations performed on this miner. Any operation history. Its historical and current faults. Some remarks. If you use the ItsMiner's maintenance to manage maintenance, there will also be its historical repair records. In general, this is a real-time status and historical archive. You can also directly operate the miner here, switch sub-account configurations, and other operations. Of course, you can also on the list of ASICs interface to perform some operations on the miner, such as restarting and other operations, which are all possible. In addition, we also provide a function, automatically check the configuration of the miners. It will find some non-compliant or irregular configuration information, such as IP conflicts, miner with the same suffix, or miner without a suffix. Then you can use these. You can use these prompts to select the miner directly. For example, this one has no suffix. We can directly select these miners to modify the box name suffix and click Apply. At this time, these miners will automatically perform this operation. Then this abnormal configuration or irregular configuration will be cleared. In addition to the normal statistics and operations of the miner, we also provide various management tools for on-site operation and maintenance, such as the temporary task list. You can select some miners, such as these two kinds of miners. Choose them and put them in a temporary task list. I can then assign tasks from this list to designated engineers for follow-up processing. Then the engineer can directly open this task list and see these miners. Then I can directly do it here. For example, if I need to restart this miner. For these miners, I have checked and found that they do have problems. I can take it off rack or directly add it to a repair list. Through this method, we can check specific miners from the temporary task list. They can be restored to normal. If some miners still have problems to be handled, they may be off rack or put them in the repair list. You can use the repair list to track the repair status of these miners. For example, these two miners we intended to repair. Staff can repair the unit here and mark its status. When the miner is repaired, as long as it is placed on the rack, it will automatically show up in the miner list. So, the temporary lists here assist on-site staff in tracking work items. There are also removal and repair orders to track some miners, and the actual tasks and miners for miner removal and repair. This is the complete miner list interface. Next, let's look at the inspection. Some people also call it a sitemap. The interface is structured into two levels of content: room and rack. If you are a container, you can also map each container to its corresponding room or rack. As for racks, we will count the corresponding IP addresses and rack occupancy. The running status of the miners on it, how much its power load is, its actual hash rate value, and so on. We can also use a tool called MapView, which is a real map of the mining farm, to view the status of the miners. Here, it actually maps each miner to its physical rack location, aligning the system data one-to-one with the actual on-site setup. As you can see here, multiple miners are marked as invalid. You can go to the physical R5 rack in the lower right corner to locate these miners, and their positions will be matched. Two binding methods are available. One is to bind miners via MAC address, and the other is through static IP address. We will talk about this later. If we switch to a map, we can have multiple layers. First, you see a fault layer. which directly displays miner fault status. We can see the relative temperature layer under the same model, which shows regions with higher relative temperatures. There is also the actual temperature, which is the actual temperature of each miner, which temperature line it is within. IPMap is the IP management layer, which records whether each miner uses a dynamic or static IP address. You can also filter through here to only view the data of some miners. We can see from here that, for example, Daniel's miner, several of his miners are running very well. Then we can go to the specific rack to check the status of the miners and perform some operations on them in batches. This is the view of the R5 rack itself. We can also apply filters by temperature, customer, and working mode. In this section, we can view the working mode of each miner. Then we can directly here restart these miners. For example, we want to restart it. We can select a few miners at random. And these miners will be restarted. This way is convenient when we face the rack to directly perform some batch operations. You can access this interface on your mobile phone as well. Open this interface directly on your phone and face the rack and perform some operations on the miners. So, for these functions, we need to configure the rack information in advance. So you can do it here. Add the factory at the beginning. Or add racks inside. This is the specification of the rack. For example, we want an 8-row rack with 10 columns. And if you have some racks, for instance, these 2 racks are actually out of service, so we can disable them. Next is the IP. What is the IP subnet of this rack? Of course, we can add them in batches. We add 10 racks. Okay, let's take an example. In this case, we can directly to add the dynamic IP network segment of these 10 racks. Then we need to choose whether to sort racks by IP, to sort the racks and miners, or by binding to the MAC address. If we sort the racks by binding method, we can select an ordering rule here, from left to right, from top to bottom, or something else. There will be a choice here. This is confirmation details. Once we click Add, these racks will be created. Then we can do some configurations. In fact, even if you don't do the configuration, many miners can be directly put on racks. For racks of this type bound via MAC address, you need to perform the MAC address binding operation. Where is this function? It's in Tool. There is a function of MAC address binding. You can select a certain rack. If the corresponding MAC address is dynamic, it will show dynamic. Static will show static. Then, start monitoring. At this point, you go to this rack and press the IP report button on each miner one by one in the order of the rack. And the miner will be bound to the corresponding rack sequentially in the same order. Okay, this is our farm map or inspection function. Miner pool. The pool module will automatically scan all the sub-accounts of the mining farm and automatically record the data on the pool side, including online and offline status, hash rate, so on. It can also record the corresponding local data, including its failure status and so on. The premise is that you need to bind its observer link to each mining pool account. Once bound, the system will automatically grab the data. The local data will be automatically recorded continuously. You can manage sub-accounts here. You can use this management sub-account to modify the URL configuration of the sub-account and which client it belongs to, and so on. You can use our whitelist feature when there are some sub-accounts are opened and added to the whitelist. If the system detects a sub-account not on the whitelist, it will trigger an alert. The system will mark these miners as a failure that is not in the whitelist. If you want these miners to automatically revert to the previous normal sub-account, you can use the automatic recovery function. For example, this sub-account. You can choose to automatically restpool and restpool to the normal state of the previous round or a specified sub-account. Here is a function to set alerts. You can set a threshold for the overall online rate and hash rate. Set a threshold. You can also set the threshold for each sub-account. Once it is set, when the overall hash rate or the online rate is lower than this value, or the value of each sub-account is lower than this value, then alert messages can be sent to the designated personnel. The alarm information is sent through email or Telegram. This is a sub-account in its mining pool. Will record at every hour online and offline status of the pool, hash rate. It also includes the current local failure situation. This data is convenient for people to do some statistics, calculate electricity bills for customers, or even some audits. This is our pool module. The earnings module is simple. It records the income of all sub-accounts, as long as you bind the observer link and record their income situation and summarize them by billing cycle. The previous modules, mainly for the operation and maintenance team, to handle faults and monitor the status of the miners. The latter modules, mainly for the operation and management of the miner. The electricity module. First is the electricity statistics. That is to say, you can, for different customers, automatically calculate their electricity bills or usage. 3 calculation modes. 1 is hash rate-based billing, calculated as the mining pool hash rate multiplied by the power consumption ratio. The other is time-based billing. It calculates charges by multiplying the miner's running duration by its power consumption. The third billing method is meter-based calculation, which requires manual data entry. In contrast, the first 2 modes support automatic calculation once the system is enabled. Well, our system can also go to the background. There is an automatic estimation function in the background to help you estimate its usage. Load monitoring. It mainly monitors three-phase electricity. Your three-phase electricity. After configuration, we can see how much load each phase. How much load is on each phase. Whether there will be some imbalance, leading to increased line losses, or electrical safety issues. Load holding function. Some farms hope that the load of their keep the load below a certain level. For example, set an upper limit here. When the miner exceeds this limit, it will reduce the load. This is for some farms that have some accidental spikes, resulting in overcharged electricity bills. So you can make such a configuration in here. What is the required upper limit and the acceptable fluctuation range? When my load drops, I will switch some miners to normal working mode to pull it up. When the load is higher than this line, I will switch some miners to low power or sleep mode to reduce the overall load. Then you can choose some miners to put into the buffer pool for this purpose. Load control. Load control is a rigid demand in many regions. We support three methods in our system. The first function is automated power demand response handling. The second one is processes automatically based on electricity prices. The third is processes automatically based on configured schedule. So, the load control is a rigid demand in many regions. There are several companies that we support. Of course, if you have more needs, we can also do the docking. After you complete the configuration here, our system will automatically receive signals from these companies. You can also set the electricity price parameters and select your pricing region. Once configured, the system will display the curves of the day ahead and real-time electricity prices. After configuring these, you can create a task. There are two control modes. One is to switch the working mode to stop or resume mining. The other is to control via smart sockets, which is rarely used. We choose to switch the working mode. Let's configure it. First, you can choose by time. For example, I choose 1. For example, I will stop at 9 o'clock, and then I'll resume at 10 o'clock. Once you confirm, the system will automatically stop the service and resume service at 10 o'clock. You can set weather to repeat this action every day. This is the time. You can set it according to the electricity price. For example, I choose day ahead hourly. If 2 hours exceed 90, that means if the electricity price stays above 90 for 2 consecutive hours, then I won't run mining during this period. If the electricity price stays below 80 for 2 consecutive hours, then I will resume mining. This is the day-ahead electricity price. You can use real-time electricity prices. The same setting method. You can even set up nested rules. Pay attention to both day-ahead and real-time electricity prices. You can also make such configurations. You can also use the load regulation signals for automatic triggering. For example, this refers to the load response signals you configured earlier. Then it's relatively simple. Once you have configured the triggering method, You can choose the next step, which miners I want to affect. You can choose according to the model of the miner, or by the model of the miner, or sub-accounts, or by IP network segment. Usually, you may select all of them. Of course, if the electricity price is only part of it. Let's choose one as an example. Then you can choose when I reduce the load, what working mode to switch it to, and what working mode to switch to when restoring load. We also have a function to prevent wake up. That means we will help you during the entire load adjustment period, no matter how others restore this miner to a hash rate state. Once we discover, we will immediately switch it back to sleep mode to ensure that the miner is not loaded or a low enough load. This is the rule for issuing commands. When issuing the command, for example, you have 5,000 miners. You don't want all miners to shut down at the exact same time. This may bring potential safety risks to power consumption, so you can batch according to certain rules. I send 500 at a time and send the command every 20 seconds, which will be safer and more stable. When the load increases, we can also make some such configurations. We can be slower to ensure the safety of electricity. In this case, we can create automated tasks for load adjustment. Here's just a few examples. These are different load adjustment tasks. If these tasks are known to trigger in advance, it will be displayed in this state diagram. What time it may occur, there is a task that will be triggered or is being executed. Then you can set up reminders. It is when the signal arrives, or 15 minutes before execution, or during execution or upon completion. In what way? By email or telegram to notify me. In this way, we can have a grasp of the situation from the beginning to the end of the entire event. If there are some emergencies, and it is being executed, we can also quit the execution. Then all these execution records and trigger records can be found in the system. This is the trigger record, triggered by electricity prices or by a power rationing signal. This is the actual execution record. What time was each instruction executed, and how it was triggered, how much load was adjusted at that time, and then you can click here to check the situation of each miner. We also provide export feature. Corresponding electricity price and load data can be exported by price interval. For example, you can select a 15-minute interval. Then export the electricity price at each 15-minute point within a chosen time period, along with the corresponding load. There's the smart plug management we mentioned earlier. If there are many smart plug, some may be for miners, and some may manage the network according to your needs. And then in the load regulation task, you can use the smart plug to execute your strategy. This is the aspect of power management. Asset management mainly includes two aspects. One is the asset management of miners, which includes online and offline, in-store, repairing, and all of them. The state of the miner in the system can be tracked throughout its life cycle. And then, for each state, there is a corresponding list. For example, the list of miners that have been removed. Miners under repair, and the miners that haven't been repaired yet, can be seen here. Then, the other part is parts. You can define your own types of parts. After defining them, when parts are put into storage, you can fill in some information about the parts. And when the parts are delivered, you can also fill in the information of parts out. In this way, we can manage the entire inventory and the inbound and outbound of parts. Then, based on the records, to do some historical statistics and asset inventory and so on. This is the asset module. Team. The team is relatively larger than the operation and maintenance team, can be responsible for team configuration. Which is the team assignment? You can create some teams to assign different people and assign them to different teams, which miner they are responsible for, whether it is effective every day or on certain days. Once the configuration is completed, you can monitor the operation and maintenance situation of the team, pool data, and local data, and you can also view his previous all the information about his shifts. For example, we can see what time he goes to work. We can see this is the data for work. This is the data when he gets off work. Then we can compare the data of commuting to know whether the state of the entire miner has improved. There are also historical data statistics, that is to say, over the past month, how many times did this team end their shift in better shape than they started? And how many times in worse shape? And so on. So overall, this module helps teams better analyze their own operational capabilities and performance. Client. Then you can configure the client's billing method here, their electricity bill, and so on. Then you can assign their miners to clients and allocate the client's miner. Then the system will automatically generate bills for him based on his billing method. This function is for the operator of the farm. There are also some other auxiliary functions. Operation records. The operation records every action taken on each miner every time. Who did what, on which miners, and how many succeeded or failed. Then the temporary task ticket is for task tracking by the on-site O&M team. The repair list is used to track maintenance work. Configuration tools. One lets you batch configure static IP addresses. After you have configured these basic information, fill in which rack you want to monitor. It may now be a dynamic network segment. After start monitoring, then click IP report one by one. It will assign and occupy IP addresses one at a time. Bind the MAC address to seat. Select your rack and then monitor it. You can press IP report. It will bind the miner to the position. This is the main function of our system, and some peripheral functions. Here we can see the backstage, the monitoring server's scanning situation, usage guidelines, switch between Chinese and English. Users can subscribe to alerts for major events at the farm, and so on. Okay, so this is our view of the farm, the overall operation and maintenance management, an introduction to ItsMiner. If you are interested, you can try it right away. The data monitoring for the liquid-cooled mining container is under the inspection section. After we set up the liquid cooling container ID for each container, for different containers, you can get the ID from the enterprise of the container. Know where to find this ID, and then put it here and enter it. Then we can view the corresponding liquid cooling data. The system will automatically obtain the liquid cooling data. We can see on the right a schematic diagram of the entire liquid cooling system, including some data we need, including current and voltage, and some electrical loads. The total accumulated power usage, including the hourly data, 24-hour electricity consumption, and historical cumulative total. There are also the inlet and outlet temperatures of the liquid cooling, then corresponding to the schematic on the right. The inlet water is below, which means cold water enters. The cold liquid enters the container. Then, after the hot water comes out, it goes through a cooling system. There are also some other pressure valve values, and the frequency of the circulating pump, and so on. We can also obtain more data. However, this depends on the data your container can provide. We will put them here for your reference. You can also do this in batches. When you're creating these containers, just fill in the data for each one. Once you create it, the system will automatically obtain these data. This is for the liquid-cooled container. Monitoring of liquid-cooled data.